Get started. We're here because system dynamics is our common language. And the topic here, I apologize for the music if it's too loud. Better model construction. Okay, here we are. I don't know every single attendee, but I do know many of you. The system dynamics method, the software, and the problem domain are the three things necessary to actually start doing system dynamics modeling. So we have a little bit of a challenge. As I said, I don't know who is attending, but you might have little or no conceptual knowledge right now of the method. You will, of course, after the conference is over. You may have little or no syntactic knowledge of the software you're about to use. But hopefully you're familiar with, or at least you're very eager to learn about the problem domain you're about to work in. So this is my claim again. These shapes and their sizes represent, I don't know, the scope of each of them. The system dynamics method is large and can handle many, many problem domains. So today I want to give a little bit of knowledge about the model construction process. And that's it. Let me go back a slide here so you see it. I truly believe that most of the software that we use has much more capability than solving system dynamics based problems. And that's why I put this circle quite large. Many times we find we need to do things that complement or extend the system dynamics methodology. So here we are. Now we'd like to be modelers. What is it that we are creating? Are we creating a model, which is in all cases an abstraction from reality? Models cannot duplicate reality. Then are we adding an interface to our model to allow others, maybe us, to have access to the model, that is the stocks, the flows, the auxiliaries, the connectors, the constants, and manipulate the model inputs and see, of course, the model outputs. If we put those two together, this is the terminology we use both in teaching and in our business, we're building an application. Okay. And then finally, what most people forget is we typically have to prepare some kind of report. How do we explain what the model is and does and what are its results? So a little bit more on terminology. Let's imagine you're doing a project in this problem domain, and it seems to involve energy, surface and groundwater, something to do with the economy and population. In our modeling attempt, we try to segregate or aggregate variables that belong to each of these topics in a separate module. Get my pointer going here. Separate module. All that put together is equivalent to the model. If we then add a user interface, we get an application. It's a simplified way to show those text descriptions. Now, those of you who are students, and as Jay Forster said, he was always a student of system dynamics. You may not be adding an interface, but I think it's something to be aware of because it can take a tremendous amount of time. And there's a lot of work on how to build interfaces and styles and rules of thumb, etc. Okay, more working definitions. A module, a separate part of a model. Ideally, it can stand alone with little exchange of variables with other modules, to the point that a module may be reusable. I have a generic population growth model that I've used at least 100 times. I just copy and paste it into the new problem domain model, change the names of the variables. That's an ideal. A model then is all the code, all the variables required to represent the problem you're dealing with. And then interface is just access. We'll see a little bit more on that in a minute or so. It's access for stakeholders if they would like a flight simulator, or if you'd like to run what we used to call a chauffeured model running session. And of course, for you, you need to add interface elements to your model in order to debug, be sure you're modeling correctly. And then finally, again, we like to stick to this terminology. Now, depending on what tool you're using, as far as I know, the three major tools don't use the word module. I believe in Vensim, they're called views, in Stella, sectors, and in Studio, they're called constructor diagrams. You just have to learn that syntax. So, all precursors, right, to construction. So in a model that has an interface, which we now call the exogenous variables. At a minimum, exogenous variables might be the initial values of your stocks. And typically it's data from external sources, business reports, government data sets, etc. Then, of course, there's what we do, the endogenous variables. I call them the internal calculations or the system dynamics. Then there are variables that you've created or your team specifically to enable an interface. You might do aggregations, you might do weighted disaggregations of a value, you're adding control objects and graphs and tables, sliders, all kinds of things that might require a variable that isn't really necessary to manage the problem you're trying to solve, but it is necessary to enable the interface or the flight simulator. And then finally, there are the variables that you yourself create for testing and debugging. We do this all the time, especially when we're working with teams of people. Lots of people want to see things presented in different ways. Those of you who have done a modeling know this might be very useful. Now, my claim is that every variable in your model must fit in one of those four categories. If not, I'm not sure what it is you're doing. Okay. Then finally, hopefully you see this animation, you have to decide how much of those do you expose to the user interface. Because obviously you're not going to give access to every variable, nor are you going to output every variable. But having this common terminology is very helpful, even if you're working alone. So what was the motivation for this? Way back in 2009, I started to worry about, I guess, model construction quality. So for the 2018 conference in Reykjavik, I downloaded, I think it was 325 models that were presented at the international conference between 2009 and 2017. And I did some basic descriptive statistics. For example, what's the maximum number of errors per variable? Okay. The software packages told me one, but imagine this, you might have a unit error and a logic error, but the first check is for unit errors, and that's why the maximum is one. And the converse, or maybe the reciprocal of that, is the minimum number of variables per unit error is also obviously one. Let's go forward. And then on average of the 325 models, I believe I could only run 294 of them. The rest would literally not run, but they were submitted to the conference. Of the remaining 294, I believe, 20% of all the variables in all those models had errors. There was one model that had a total of 8 variables, and at least one model that had no stocks, no levels. This made me quite a bit nervous. I call that the obvious and the odd. Now, I was not able to run and dig deep into that many models, and I must apologize. I did not own a license to IC Systems Stella at that time. So I'm not exposing any dirty laundry from Stella modelers. Here's a little plot. Notice unit errors on the y-axis and number of variables on the x. The red line shows models where every single variable had a unit error. And the green line shows models where none of the variables had unit errors. Why am I concerned about unit errors? First of all, it's the easiest to check, and it's the easiest way to have your model fail when reviewed by someone. Okay? So after all this, the definitions, the descriptive statistics of models from 2009 through 2017, let's construct some quality models. How will we do this? How will we get all those models on the x-axis? Well, here's a problem. What's quality? I think internally we all have a feeling about that word. In our daily life, when we purchase and consume things, we have a good idea of what quality is. Dictionary told me it's a state of being free from defects, deficiencies, and significant variations. Not very helpful. And you also have to have a standard if you're going to find defects, deficiencies, and significant variations. Okay. Why do we care? Right? I believe, after many, many years of modeling, alone and in teams, it reduces the costs of modeling. It protects your reputation, develops trust, leads to further work. The late Andrew Ford, Andy Ford, to many of you, told me, Len, the best outcome is getting your client to hire you again. And finally, quality will promote our methodology. What is it in the context of SD models? What are those defects, deficiencies, and variations? What are the metrics? Can't answer that right now. Are there processes that would assure quality modeling? If you look through the literature, especially the System Dynamics Society bibliography, which I highly recommend, it's got somewhere over 11,000 references. You'll find many articles on the modeling process, how to approach clients and stakeholders, how to record what it is they're telling you. But there's very little on mechanics. In my software engineering days, there's a very famous experiment done with students asking them to solve a problem with a computer program. The professor secretly told each team to maximize something different. To solve the problem, but one team, for example, was told to maximize the number of lines of code. Another team was told to minimize the number of lines of code. And back in those days, they were actually told to minimize the CPU, central processing unit time. What are you doing? What are your team members doing, either consciously or subconsciously? What are the standards? As of today, as far as I know, there's no universal agreed upon set of standards. Okay, there is a D memo. Now, let's see, that was 2021. So a little bit more than, 24 years ago, some students at MIT wrote a model construction quality standard for Vensim. And then I know the PowerSim Studio user group took that and added to it, and they have an informal set of standards. And finally, you can always use SD software to build non-SD models. I mean, they are computing languages. Don't fear, don't be worried. It may be at the start, there's not much system dynamics in your model for many reasons, but don't panic, don't worry. Okay. Let's assume you're an instructor, and I know that there's at least one instructor out there, if she's still on, who has to evaluate student work. So what I've got here is model number 1 and model number 2. And what I'm going to measure is, assuming I have all these quality standards and I can measure them, this is the percentage that model 2 achieved in a certain quality domain. And here is the percentage that model 1 achieves in a certain quality domain. And let me go forward here. Okay, so here's some potential quality attributes. How about units? So you find out that the Model 2 team, I don't know, maybe that's 75% of their variables have the correct units. And Model 1, to me, it looks like, 15% of their units are correct. Which model is better? I don't expect you to answer me, but think about that. Now let me add another attribute. Maybe. Here we go. How about naming? Is naming a quality attribute? If you can see behind me, I don't think you can. I'm trying to see where those books are in my background. I'm moving around. Somewhere in my background is a series of books written for early versions of iThink and Stella. And the majority of the models in those books have variable names like X, Y, beta, etc. Is that quality? How about layout? How complicated a diagram is it? Don't know. Now, what I would like to say though is at least this variable, there's a binary rule. Either you have the correct unit or you don't. But naming and layout are much more subjective. What are we going to do when it comes to quality? Okay, so I went and looked at my old problem area, software engineering. And they have a thing called the capability maturity model. And these are for organizations that build computer software. There are 5 stages. Some companies are what are in what's called stage 1. They have very few processes, and success is based upon individual effort. That poor fellow or gal who put in a 90-hour week to get the work done. Second, the repeatable stage, where there are some processes, and I notice they have a typo in their presentation here. Stage 3, processes are well defined, documented, standardized for the entire organization. Stage 4, not only are there processes, but they're quantitatively managed. People are reflecting on the work they've done in modeling. And finally, stage 5, they call optimizing. Why is this important, or why was it important for them? If you were to bid on a software building project, your organization is evaluated as to which stage you're in. The higher the stage, the more points you get on winning that request for proposal. So the key word, though, is process here. Don't answer this one either. You have a process that you, your course, your organization, your company, your university uses when building models. So what do we mean by building a model? So fortunately, Nikki Zimmerman let me use these slides from one of her webinars years ago. We typically do problem definition. From that, we discover the key variables. Hopefully, we draw behavior over time graphs and eventually end up with causal loop diagrams before we put our mouse to the model. Then we build stock and flow, enter the equations, simulate, and analyze. Test, 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 test. I'm concerned in this webinar about stock and flow diagrams and model equations. There's a tremendous amount of material on those other topics, but not on these two. So I don't know where all of you are, if you can easily bring up the software that you use. Okay, you might want to do that. We're going to build a model, or I'm going to try to build a model. Simple population growth model. An initial population of 1,000 persons. A population which is the integral of a growth rate whose initial value is initial population. And then a growth rate of 1.1. Depending on the software you use, the unit might be percent per year or 0.011. That has a unit of 1 over year or dimensionless per year. And I believe if you're in Europe, it would be 0,011. Likewise here, be 1,1. Okay? Everybody with me? Anybody, I don't know if we can interact or not, Rudolph, but does anybody see anything strange about the way I laid out these equations?
Eileen, we only have the workshop tomorrow, so I think everybody's still in conference mode today.
Okay, great. I'll point out the oddity here in just a minute. Oh, and then finally, the growth itself is population times the growth rate. Okay, and of course, I completed my problem definition stage. I've identified the variables with stakeholders. I've set my start and stop times and my DT, my delta T. So you should have this presentation as a PDF, or soon we'll have access to it. These are the kinds of things that I do before I put my mouse on my canvas. Has a time unit been established? Check. Has the duration been chosen? Check. Have a set of units been established? Gee, I'm building a model that deals with people. I should probably have a unit, person, people. I need liters, I need watts, I need kilowatts, et cetera, et cetera. And we suggest using standard international units as much as possible. So if you're in the UK or the United States, gee, we don't use meters and liters. So make sure to base all your units on standard international units. Got it. Is there an issue with software compatibility? Have you picked a naming convention? And this is where I'm talking about the strange words on the previous slide. And here it is. Stocks, the first letter of every major word begins with a capital letter. Flows and auxiliaries, or connectors, depending on the tool, are all in lowercase. Constants are in all caps, and I put this in as a joke. Why? Two reasons. The D memo from the MIT students in 2001 suggested this naming convention. And number two, if you print equations in a report, it's very easy for the report reader to know what's a stock, what's a flow, and what's a constant, right? You don't have to put another column describing what they are, just a footnote. Very important. I've submitted papers where people have wanted to see the model code. No thanks, but we had to do it anyway, and we used the naming convention. Okay. And if you're going into detailed models, which I guess you'll find out more about tomorrow, you have a preliminary set of ranges and subscripts. How disaggregated a model are you going to create? One tip is don't do that at the start. Get your dynamics working and then add that kind of detail. Okay. I don't know if we can do this, probably not, but we'll pretend. Here are the model specifications. And this is what you'd see. And hopefully tomorrow you'll see something like this. If you're using Ventana's VenSim and you put all these variables on your screen, you'll see something like that. And note I'm using the old style VenSim symbols here. If you do it in PowerSim Studio, this is what you'll see. Warnings and basically error messages. If you do it in Stella Architect, this is what you'll see, right? And sort of a yield sign, a warning sign on all the variables. Okay, now note the naming conventions again. Also note a construction quality recommendation that any stock whose initial value is not 0, our modeling team requires that you create an initial value. Okay, for non-zero initial values. Okay, now you've got that done and you go to the definition windows. Model view in Stella or f of x in VenSim. Studio doesn't have anything like that. It only has one development window. That's what you'll see in VenSim. Everything turned black. Studio won't do anything different, and Stella will keep up the warnings. That's relatively recent that Stella has done that the warnings are there during construction and during definition of the equations. So a little Anecdote: the first year that the System Dynamics Society did summer school, someone many of you might know, Eric Preutz and I managed the beginner class. We gave all the students on a problem on a piece of paper. And we asked them to do things like draw a circle around what you think a stock is, underline what you think a flow is, et cetera, et cetera. They finished it. I think we were using Vensim, if I remember. They opened Vensim and, we gave them some time. And then, 15 minutes later, every single hand in the classroom went up. Eric, Len, my screen looks like this now. I've created 30 or 40 variables and every one of them is black. What do I do? Where do I start?
Len?
Right? Yes.
Sorry to interrupt, but we have about 5 minutes left before we have to do the panel discussion.
Got it. So I'm going to jump ahead. Don't model this way. And again, you should have these slides. This will be my last approach here. Use outside in. Put your constants first. Second, add stocks or levels. Third, iterate through your auxiliaries and rates. And do this module by module. Okay? I'm going to zoom through here. I hope I don't make anybody dizzy. If you want to become an expert modeler, you really enjoy system dynamics as much as I do, critique other people's work, and, if possible, find models in a language you don't know and try to convert them to the language that you use. I'm going to skip this because you have it. Skip this, you have it. I'd like you to do this, though. Close your eyes. I can't see any of you. Think of a realistic quality goal for your model. For example, my models will never have a unit error. My variable names will be clear and unambiguous. Next, picture a future, sometime in the future, where you've achieved that goal. All your models are fantastic and well built. Are there any obstacles between you and that goal? Overcome them. And don't stop working until you're proud of your work. Now you can open your eyes and basically don't have that be someday. Make that day in the future today. Thank you, Rudolph.
Oh, thank you, Len. It was quite informative. I think that is now for the question session. For the previous 3 speakers, I think all of you can please quickly switch on your cameras and